It has not even been 2 weeks since the historic success of Chandrayaan 3, but once again, ISRO is going to create history. Aditya L1 Mission. Today ISRO is not looking at the moon, but at the sun. Let's understand this mission in depth in this video. Aditya L1 is India's first mission to study the sun specifically, but like Chandrayaan landed on the moon, Aditya will not land on the sun. In fact, it will be observing the sun from a distance. In fact, this spacecraft will be closer to the Earth than the sun during the mission. Specifically speaking, after the launch, it will go 1.5 million km away from the Earth and will orbit from the Lagrange Point L1 in a halo orbit. It will take about 4 months to reach that point, and once it reaches there, it will stay there for 5 years and observe the sun. That's why it is not just a spacecraft but also a space observatory. Now, the first question that comes to your mind is, what is this Lagrange point? Lagrange points are those unique points in space where the gravitational force of two celestial bodies balances out. If we consider the Sun and the Earth, we get 5 Lagrange points. You can see on the screen where these 5 Lagrange points lie. These are the points where if we send a spacecraft, the orbital motion of the spacecraft, the centrifugal force, will be cancelled out by the gravitational forces of the Earth and the Sun. What is the benefit of this? We get stability. Whatever spacecraft we send to the Lagrange point, we don't have to make almost any effort to maintain it at that point. Spacecraft will conserve fuel, and with the Earth's revolution around the Sun, the spacecraft will also keep revolving. Longer missions can be carried out with this. The second benefit is continuous observation. If we take the example of Lagrange Point L1, anything that we send to L1 will be continuously in a position from where both the Earth and the Sun can be observed. And the Sun and the Earth will never be hidden in each other's shadows. Just think about it. When we send a spacecraft to a lunar orbit, like the Chandrayaan, or if we send one to Earth's orbit, by revolving around the Moon, the Earth is hidden every so often. Similarly, by revolving around the Earth, the Sun will get hidden. That's why Lagrange points are so important, and Aditya L1 will be placed at the L1 position. That's where it got its name, Aditya L1. The other space agencies that have sent solar observatories before this have been placed at L1, like the Solar and Heliospheric Observatory. In short, SOHO. This was a joint mission between NASA and the European Space Agency. L1 and L2 are the most important Lagrange points because they are closest to the Earth. The famous James Webb Space Telescope has been placed at L2 point. At L2 point, the Sun will be hidden behind the Earth. And because this telescope has to see light years away to the depths of the universe, it is necessary to cover up the Sun's light so that there is no interference. That's why the L2 point was chosen here. But getting back to Aditya L1, what will it study about the Sun? To understand this, we need to know a little about the Sun. The Sun of our solar system, its diameter is 109 times bigger than Earth's. It weighs 333,000 times more than Earth. If you want to visualize Sun's size in comparison to Earth's size, you can see this animation. 1.3 million Earths can fit in a Sun. Just like there are different layers in the Earth, core, mantle, and crust, similarly, there are different layers in the Sun as well. There is a core in the Sun as well. Nuclear fusion reactions take place in the core, where hydrogen and helium gases are converted into energy. This energy produces sunlight and heat, which we feel on the Earth as well. The core's temperature can reach up to 15 million degrees Celsius. Right outside of it is the radiative zone. 70% of the Sun's radius is formed by the radiative zone. Then comes the convective zone, approximately 30% of the Sun's radius. Here, energy is transferred through convection, that's why it's called so. After this comes the surface of the Sun, which we have named the photosphere. Even though we call it a surface, but in reality, the Sun doesn't have a surface like the Earth's surface, because there are only hot gases and plasma. So, it is also called the lowest layer of the Sun's atmosphere. Here, the temperature is relatively colder, 5,500 degrees Celsius only. Above this, there is a layer of chromosphere, where the temperature starts to rise again. It starts at 6,000 degrees Celsius and reaches up to 20,000 degrees Celsius as you go up. Then there is a thin layer called the transition region, and after that comes the outermost layer of the sun, which is called the corona. This corona has nothing to do with the coronavirus. The corona layer contains extremely hot plasma 1 to 3 million degrees Celsius. One question you might ask is, why is the core of the sun so hot but the surface gets colder and the corona layer gets so hot again? This question is still a mystery for scientists. It is possible that Aditya L1's space mission will reveal some secrets here. Scientists have their own theories about the reason behind this, but for sure, no one knows the exact reason. When we see the sun from the ground, we usually see the layer of photosphere, but when there is a solar eclipse, we see a reddish glow around the solar eclipse. That is the chromosphere layer, and during the total solar eclipse, that layer is also hidden and only the corona layer is visible. It forms a faint halo around the sun. Aditya L1's mission is to study the three topmost layers of the sun: photosphere, chromosphere, and corona. But how will this be done, millions of kilometers away from the sun? Before talking about the instruments on it, we have to understand the things emitted by the sun. First of all, we all know that heat and light is emitted by the sun. This is very obvious. Apart from this, all kinds of electromagnetic radiation are emitted by the sun. Not only our visible light, which we see with our naked eyes, but also ultraviolet radiation, UV rays, which can cause skin cancer, infrared radiation, radio waves, X-rays, gamma rays. X-rays and gamma rays are also harmful radiation, but our Earth's atmosphere protects us from them. But apart from all these, the sun also emits solar wind. Solar wind is basically a huge wave of charged electrons and protons. When this solar wind interacts with Earth's magnetic field, we get to see the northern lights. This beautiful light that we get to see in countries like Sweden, Finland, and Iceland. Apart from this, the sun emits coronal mass ejections, CMEs. These are the big bursts of solar wind and magnetic fields. And then, the sun sometimes emits solar flares, which are the intense flashes of light and energy. In many science fiction movies, solar flares are mentioned. Like in films like 2012 and Knowing, there is a horrific solar flare, which ends up destroying the world. To measure all these things, there are 7 instruments installed on Aditya L1, which can be called the 7 payloads. First, Visible Emission Line Coronagraph, or VELC in short. It will study the corona layer and observe the coronal mass ejections. Second, Solar Ultraviolet Imaging Telescope. In short, SUIT. It is tasked with imaging the sun's photosphere and chromosphere in the ultraviolet spectrum. Third, Solar Low Energy X-ray Spectrometer. In short, SOLEXIS. And fourth, High Energy L1 Orbiting X-ray Spectrometer, in short, HEL1OS. Both of them will study the X-rays emitted by the sun, especially the X-rays emitted during solar flares. Fifth, Aditya Solar Wind Particle Experiment, in short, ASPEX. And the sixth, Plasma Analyzer Package for Aditya, in short, PAPA. These two will study the solar wind. The last payload is the magnetometer MAG, which is used to measure magnetic fields. The magnetic fields that reach this L1 point. 4 out of these 7 payloads will directly study the sun, and the remaining 3 payloads will take measurements around the L1 point. By now, you must have understood that to take these measurements, it is necessary to get out of the Earth because the Earth's atmosphere prevents a lot of radiation, X-rays, and other things from reaching the Earth, which is good for humans but not good enough to actually study them. Talking about the other missions related to the sun, in 2018, NASA launched the Parker Solar Probe in collaboration with the European Space Agency. Its purpose was to make direct contact with the sun's corona layer. Apart from this, there was a solar orbiter which was launched by NASA and ESA in 2020. All of them had the same purpose: to understand the sun better, especially the harmful rays that are emitted by the sun.